Okay guys, welcome back. Now we're gonna talk about the oxygen cylinder. It's pretty straightforward, but it's also an essential piece of equipment. So I wanna make sure that we all have a good understanding of what it is, how it works, and what we need to do to keep it working. The oxygen tank itself is this large cylinder plus this bronze valve right here. So this is the tank body, and this is the valve. It's made of steel. It generally holds about 2,000 psi, or pounds per square inch, of gas, specifically medical grade oxygen if you're dealing with medical oxygen tanks. So this is going to hold a bunch of nearly pure oxygen. I believe it's like 99% oxygen. So this is more pure oxygen than your oxygen concentrator. So if you have a patient who is really oxygen dependent, the oxygen tank will be better for them because it provides a higher percentage of oxygen. So now I'm going to tell you how to change the cylinder. You most likely will not be expected to do this yourself, but it is still very important you have the capability of doing it, because in the future you will be required to change these when you're providing oxygen to your patients. So first thing you're going to do when you are changing the oxygen cylinder is, one, you're going to do it before you run out. You never wait till you run truly out of this, because then your patient will be without oxygen. You always want to have a backup plan. So when this starts getting down below 10% of its starting capacity, which is usually around 200 pounds per square inch, you want to start replacing this. So you're going to first transition your patient from this tank that they're using to another tank, another oxygen source, and then you can go ahead and discontinue this one and change it out. So to change it, the first thing we're going to do is we're going to turn off the oxygen flow, right? So we'll say it was flowing at 5. We're going to turn that off, right? So our regulator here is off. The next thing we're going to do is we're going to use our oxygen tank key or oxygen tank wrench, and we're going to turn off the main valve on the cylinder itself. An easy way to think of it is this is 2 pieces, and each piece has its own valve. So you just turn off the valve on both pieces, right? You turn off the valve on the regulator and you turn off the valve on the tank itself. So now all the pressure is stored down in this tank, right? There's a little bit of residual pressure in this regulator. So the next step is we're going to release the residual pressure, right? So we're going to open this and just let it drain until it's out. So you can probably hear it whistling as it's coming out, but this is closed, right? So that was just the pressure that was left over in here, but this is closed, so no more pressure is coming up into here, no more air. So now the pressure is equalized. So in the regulator itself, there's no pressure other than just regular atmospheric pressure. So now we can go ahead and take off the regulator, because this valve, the main tank valve, is controlling the pressure. So we're going to use just a regular crescent wrench, and we're going to go ahead and unscrew this right here. Right, and you always want to be make sure you're not standing in front of the glass, make sure you're away from it in case there is some sort of residual pressure we didn't expect and something pops or explodes. We always want to make sure we're a little bit away from it so that we're not going to be injured. So unscrew the nut. And now I'm going to get rid of this tank and get a new tank. All right, guys, I got my new tank here. So now I'm going to take this regulator, I'm going to put it back on the new tank. So the way you're going to take the new tank and put the regulator on it is basically the same process we just did in reverse. You're going to set the regulator into the main tank outlet. You're going to tighten it. Just finger tighten it as best as you can until you cannot anymore. Okay, now you're going to finish tightening with a wrench. Okay, so now it's tight on there. We're going to make sure that we have our bottle cleaned and filled appropriately with water. So it's filled with water, it's cleaned. So now this has been tightened, or the regulator has been tightened onto the tank valve outlet, and we're gonna go ahead and open the tank valve. But we're gonna make sure that we look away from our pressure gauge, because if there is a sudden increase of pressure and this glass breaks, we don't want our face, in front of the glass. So we're gonna stand off to the side and we're gonna slowly open the main tank valve. And we're gonna see the pressure start to increase on our main tank valve. See, we see it go up right there. Looks good. Okay, so now that is opened. Now I'm gonna test to confirm that this will open and my flow meter ball will raise. Right? Yes, it opens up. That's good. I have oxygen flowing and I can feel oxygen coming out of here. So now I've confirmed it's working. And now I can go ahead and initiate oxygen therapy with my patient using this tank. So one common question I get a lot is, why is it not all the way full? And a lot of times the tanks are only filled to about 2,000, maybe a little bit more than 2,000 PSI, and that's considered full, right? It's kind of like the speedometer in a car. It says it might go up to 180 kilometers an hour, but we all know that car is not gonna go 180 kilometers an hour, right? It's a similar thing. And just because the max gauge pressure is 3,500, it doesn't mean that's what the tank started at. So you don't have to turn it on and be like, oh my gosh, my tank is half empty. That's usually not true, okay? So just make sure when you get a full tank, you take note of where it starts. That way you have a reference point to see how fast it is decreasing. As far as a couple important points about the regulator, so there's a valve ring, like a rubber seal that's supposed to be inside of this lid, okay? So if you go look up inside of here, I'll attach a picture, but if you look up inside of there, there's supposed to be a ring that basically seals the lid onto the canister. So you always want to make sure that's in there, otherwise you'll get air leaking out of the sides. Additionally, many times there's supposed to be a rubber ring seal in this white portion as well that attaches the canister to the rest of the regulator. So there's supposed to usually be a rubber seal inside of here. I don't know if you can see in there, but there's a rubber seal. So you want to make sure that's in place as well. And then finally, when you are filling your canister with water, you always want your humidifier bottle to be clean, right? Because the air comes across this regulator, down through this blue straw, and then is bubbled out through this white tip right here into the water that then bubbles up. And now this humidified air comes up out of a hole that's on the inside of this lid, down this Christmas tree portion outlet that is then attached to some sort of tubing, right? So you always want to make sure that this bottle is clean, because anything that's in it gets in the water, and you always want to make sure the water is clean, because anything that is in the bottle or in the water is going to be in the air that then the patient breathes in. So if you have mold or dirt or something in there, that's literally going into the patient's lungs, and we don't want that to happen. So always make sure your humidifier bottle is clean and filled with clean, sterile water, or if you do not have sterile water and your medical director approves it, distilled water can be used. Another point with the humidifier bottle is that oftentimes if this is filled with too much water, it will actually bubble up and start coming out of this outlet. It'll go through the tube and potentially could go to the patient. So you always want to make sure you don't overfill this so it starts bubbling over and leaking into the tube that's going to the patient. To the same point, you also don't want it to be underfilled so that the bottle is not effectively humidifying the air. So always make sure that your bottle is filled up enough that it is effectively humidifying the air, but not so much that it is bubbling out and bubbling over and sending water out of this outlet through the tube to the patient.